Okay, welcome back. Today we're going to discuss 2024 VCE Specialist Math Exam 2, question 5. So this is a composite function. So a composite function can be difficult to integrate. So how do we integrate or differentiate the composite function? So today we focus on differentiation. So derivative of composite function. Before I start, just remind everyone, please subscribe this channel so you do not miss any latest updates. I also show your support to this channel. Okay, what the question is, we got two functions. One is fx, which is sine x. The other one is gx is sine 2x. They are using the sine function, but we want to give two different composition. One is g is in the front, so f is combined with g function. So next one is f in the front, g and after that. So let's explain what is the gf first. So g circle f. So this is the dot graph is g circle f. The continued graph is f circle gx. So that graph is very different. And then we're going to see what is the composite function so that we can solve for differentiation. Okay, first let's do y equal to g circle f first. So I'm going to substitute. So let's say g circle f means the function fx is inside of g function. So that means we substitute fx equal to sine x into g. So what's a g? G is sine 2x, so x replaced by sine x. So that's the composite function. So that's the first step. So we solve for first one. Then we're going to find the local maximum, because the question said also we need to find the coordinates of local maximum point. So in order to find the local maximum, we obviously see GF is between only from 0 to pi over 2. So the local maximum is this, somewhere here. And there's another stationary, which is here. But that one is not really, because that's more than, this is more values, high values than this. So look like this is the local maximum. So I'm going to solve this. In order to solve a local maximum, we need to do differentiation. So we differentiate y with respect to x. So let's do that. Let's do a differentiate. That's because the composite function, we're going to do two steps. Step one, we do differentiate sine, which is cosine. So we copy exactly the same. We don't do anything. 2 sine x. Then we differentiate the 2 sine x. So I'll put a dash outside. Then that's the answer will be sine is cosine, then 2 to the front. So now we got two null factors. One is that, one is So we call this 2 equal to 0 to solve for x. So that one is simple. Cosine x equal to 0 within the 0 and pi over 2. So x, one of the x is pi over 2. But this one, in order to solve this one, we need to let this equal to pi over 2. Because the cosine pi over 2 is 0. So we move 2 to the right, it becomes sine x equal to pi over 4. Now, this one's certainly, so we got two answers. And then for this one, we need to find the x. So we need to use the inverse of sine pi over 4. So the x1 is pi over 2, x2 is 0.903. Excuse me. So which one is correct? Now, if you look at the pi over 2, so look like this is not a maximum. So look like this one will be the maximum point. So we choose the x2, 0.93. Then we need to substitute to the original function to find a y. So we find a y is 0.99 using the calculator. So we substitute pi over 4 into the original function. Pi over 4 square root 2 divided by 2, cancel 2 out. Sine square root 2 is 0.988. So the local maximum is, the coordinates is that. So using, actually question using the 1 decimal. So it should be 1 decimal should be 0.9 and 0.9. So that's the first question A. Then we need to find out the range. So from a range, sine something to sine x, we know sine always between -1 and a +1. So therefore the range is that. All right, let's do the question B. Question B is the other way. So we put a f in the front, g after. So we still do composite function, but a f in the front, so means g built into f. So what's f? F is a sine x, then gx is a sine 2x. So that's gx. So that's the second composite function. So that's a different to the first one. So if you look at the first one, it's different. Then you need to differentiate derivative of the fg. So we differentiate sine is negative cosine. Then differentiate sine 2x. Sine is cosine 2x, then 2 to the front. So the answer is that. So if we want to show this equation, cosine 2x, cosine sine 2x is equal to 0 has no real solution. So how do we do that? So if you want to solve no solution, we say if that's equal to 0, so this value has to be pi over 2 because cosine pi over 2 equal to 0. So sine 2x equal to pi over 2 is greater than 1. So we know sine x, regardless of x value, is always less than 1 and greater than -1. So therefore, it's less than 1, but it's greater than 1. So therefore, the x has no solution, no real solution. So now we need to find the x value of the stationary point, f circle G. So we let this differentiation of the fg equal to 0. So from the previous question, we said this is the first null factor has no solution. So therefore, the only solution equal to 0 is the second one, which is cosine 2x equal to 0. So 2x equal to pi over 2. Or, because within this domain, remember we have a 0 to 2 pi, so we have another answer is 3 pi over 2. So two answers, pi over 4 and a 3 pi over 4. So we want to find the range for the fg. So again, same sign always less than equal than 1 and then greater than -1. So the answer is same. So that's it. We are complete this solution for composite function, and I hope you enjoy it. And please don't forget to subscribe this channel and to support this community. Thank you again. See you next time. Bye-bye.